is we are going to multiply the inside. Okay, so what's 2 times 72 times 5?
Can I simplify it?
So you simplified it first and then multiplied?
Yeah.
Okay, let's do that then. All right, so on here, if I'm going to simplify first, can I simplify the square root of 2? No, so I'm just going to leave that guy underneath. What about 72? Can I break him down at all? All right, what can I break him down into?
3 times 2 and then like that side and leave the 2 side.
Okay, so 2 times 36, and then we could break it down into what? What can I break? Okay, and so since we have a pair here, we can pull one of these out, and that's going to give me 6 radical 2. Okay, so if we break that down again, we see that we have a pair of 3s and we have a pair of 2s. What's 3 times 2? Okay, so we're going to have 6 radical 2 when we simplify. Okay, and then can we simplify the square root of 5? So now we can multiply all the stuff on the inside. So what's 2 times 2?
4.
And 4 times 5? Okay, so right now we have 6 radical 20. Can we break down the square root of 20? Yes. So what are factors of 20? Okay. And what are factors of 10? We see that we have a pair. We're going to pull that out to the side. So 6 times 2 is going to give me 12. So we have 12 radical 5. If this was a multiple choice question, how I would do it is I would take this and write it into my calculator and my answer choices, and they should have the same decimal. Okay. All right. On the next one, is the sum of the square root of 3 and 1/3 rational or irrational? Okay, so what is rational and irrational? What's the definition of that? Okay, if I tell you that irrational are things like pi or, say again? It goes on forever. Okay, but if it repeats, is it rational or irrational? Okay, so for instance, like 1/3 repeats. Yeah. Now, if we do 1/3 plus the square root of 3, does that go on forever? Yeah. Does it ever repeat? No. So is this rational or irrational? Irrational. Irrational. Okay. What about the next one? Is the sum of 0.0675, and that's repeating, and 8 rational or irrational? If it's repeating, is it going to be rational or irrational? If it repeats, is it going to be irrational or rational? Rational. Okay, this line right here says, hey, it's going to repeat. It's going to continue on. Are we okay on that? If the decimal repeats, it's rational. All right, on the next one, a rectangle has a length of 2 meters and a width of 40. What is the perimeter? How do we find perimeter? Add up all sides. So if I have 2 on one side, 40 on the other, 2 on this side, 40 on the other, what's 40 plus 2 plus 40 plus 2? Close.
84.
84. And remember, we always want to put, ooh, wait a minute. You know what we didn't check? We didn't check and make sure that all of our units are the same. So look at this.
Oh, meters and centimeters.
Right. So we got meters and centimeters. Do y'all know how to convert from meters to centimeters and vice versa? Okay, so back in like 8th grade, you learned like a little saying that was King Henry died by drinking chocolate milk, maybe?
Well, I heard of that.
Okay. Or you might have heard something else like, I don't know, there's a bunch of sayings. But we've got meters, and we're trying to go to centimeters. So what we're going to do is we're going to move the decimal place over twice to get to centimeters. That means that with this 2 meters, we're going to move the decimal place over 2 times, and we're going to put 2 zeros. So we have 200 centimeters instead of 2 meters. So now we can add up all of our sides. So we have 200 on the side, 40 here, 200 on the side, 40 here. So what's 200 plus 200? And then 40 plus 40. So we have 480 centimeters. That one's going to probably be the tricky one. They're going to throw that in there just because. Okay, the seating plan is being designed for section 12 of a new stadium. Describe the pattern. So what's happening each time? Look from row A and then go up. Look from row A and then go up. So what are we increasing by? 3. What do you mean by 3? Are we adding 3 each time?
Yeah.
Okay, so let's look. How many seats are in the first one? How many seats are in the second one? Okay, so we went from 2 to 5. How many seats are in the third one? 8. How many seats are in the next one?
11.
How many seats are in the next one? Okay, so we are adding 3 each time. Does everybody see where I'm getting that from? Okay, so we're adding 3 seats to each row. Okay, on the next one, we're writing an equation for this pattern. So how many did we start with initially? 2. And we're adding how many to each row? Okay, so we're adding 3 to each row. And you said 3x. What does that x represent? Not the amount of seats. A seat. Let's call that the row. So for instance, if we say that this is row 0, that bottom one is row 0, then that works for this equation. If we say row B is row 1, then that'll work for this equation. If row C is 2, then it works for this equation. So we're starting at row 0 being row A. Okay. So row Z of section 12 must have at least 75 seats. If the pattern continues, does this seating plan meet the requirements? Okay, so reading that next one, does this plan meet that requirement? So how many letters are in the alphabet?
26.
Okay, so row Z is going to be row 25, right? So row Z is going to be row 25. With me? Okay, so what we're going to do is we're going to take our equation and we're going to plug in 25 for x. And when we do that, that gives us 77. So does that meet the requirement of at least 75? Yes. Okay. Because this will be 77. Okay. Once you're finished, go ahead and flip the page. So I'm going to talk about the difference between arithmetic and geometric sequences. Arithmetic we talked about in the last unit. Okay, arithmetic, we were adding a consistent number each time. So for instance, those seats, that one problem that we just did, that would be arithmetic because we're adding 3 each time. Okay. It would also be linear. Yep. Geometric is going to be your exponential. Okay, so over here on the side, love it good. There we go. Okay, over here on the side, I want you to put arithmetic. That's going to be linear. And geometric is going to be exponential. Okay, so what's the difference between 1 to 2.2? If I take 2.2 and I subtract 1, what do I get? 1.2. From 2.2 to 4.84, what am I going by? Yeah. 2.62. Yep. People weren't putting them back, so they went missing. No, like they went missing. Oh. Mm-hmm. Oh. Mm-hmm. So on the next one, what's the difference? Yeah. What's the difference? What's the difference? 10.648? 5 point what? Okay. What's the next one? $17 point some number. I got phone calculators, don't you? So I got 12.77676. Yeah. Okay. So is this going up by a consistent rate? No. So let's see if it's going up by a ratio. So if we multiplied by something each time. Well, the way to figure that out is to take the second number and divide it by the first. So 2.2 divided by 1 gives me what? 2.2. Well, let's see if we take 2.2 and we multiplied it by 2.2. Would that give us our next number? Yeah, it would. What if we multiplied by 2.2 again? Would that give us our next number? Yeah. What if we multiplied it by 2.2 again? Would that give us our next number? Yes. Okay. So this is our ratio, which means that it's going to be geometric. Remember how we have exponential and we multiply by a ratio? It's the same thing with geometric. Can you tell me whether or not the next one is arithmetic or geometric? So you're testing to see if there's something that you're adding by each time. And if that doesn't work, then you're trying the ratio. Okay, so what'd you get? It's arithmetic. Why did you say that? Because we're adding by 74. Okay, is that what you got? Okay, good. Okay, so there's two different types of formulas. And we had the same thing with arithmetic as well. But on here, we got the recursive formula. So what's going to happen with that is we're going to write a sub n, and we're going to probably put this over to the side. A sub n equals r times a sub n minus 1. Recursive means to go back. A sub n equals r times a sub n minus 1. A sub n, yeah. Got a little n. Okay, so we're trying to figure out what the rate is. In order to figure out the rate, we're going to take the second number and divide it by the first number. So what's 678 divided by 3,000 72. So what is 768 divided by 3072? I got 0.25. Is that what you got?
Oh, I got
1/4 or 0.25. Okay. So all we're going to do for the recursive formula is we're going to keep that a sub n. We're going to change the r to what we just found. And then we're going to keep the a sub n minus 1. That's it. All we do is plug in the r. Okay. Let's talk about the explicit formula. And sometimes with the recursive formula, they're going to tell you to write out what a sub 1 is. They don't always ask you for that, but they could. Okay. Okay. On the next one, it's asking what is the 12th term for this sequence that is described. Now they give us the recursive formula, but we want to use the explicit formula. So the explicit formula for geometric sequence is going to look something like this, where we have a sub n equals a sub 1 times r raised to the n minus 1. That's the explicit formula. Now, a sub 1 is our initial, r is our rate, and then we're going to plug in our n for whatever term they're trying to find. So we'll have a sub 12 equals a sub 1, which was 3, times r, which we get from that equation right there. And then we're going to plug in 12 into our equation. Really quick, can somebody plug this in their calculator and tell me what you get? I got a really big number. What'd you get? Say again. On a phone, you can turn it sideways. That's what I got. Is that what you got? I got a really large number. That's a billion. 88,391,168. Okay. That's what I got. So what you got? Okay. Go ahead and take a moment, read over the next problem. I want you to kind of underline the important pieces. This is a really long paragraph, so I want you to kind of look through what are the important pieces from this. Okay, take a moment, read that over. Okay, the podcast began its first week with 5 subscribers, and it doubles each week. The number of subscribers can be modeled by this function. Since the podcast started, so that f of 0 represents the initial amount of subscribers, it can also be modeled by the geometric sequence that, where n is greater than or equal to 1, where a sub 1 represents the first term, which corresponds to the number of subscribers after n minus 1 equals 0 weeks. How many subscribers will there be in week 9 if the initial number of subscribers is 10? Okay, so there's a lot to unpack here. First of all, we got this equation, and it's 5 times 2 raised to the x. And then they give us another one. They give us a sub n equals 5 times 2 raised to the n minus 1. Okay. So it's asking which corresponds to the number of subscribers after n minus 1 equals 0 weeks. So how many subscribers should we have in the first week? So the first week we should have 5, right? Okay, so when we plug in n equals 1, we would use this equation to represent the 5 subscribers in week 1. Okay, the rest of this is describing the rest of the weeks. So if we wanted to find week 9, if the initial number is 10, then what are we going to do? Well, we're going to change our equation to be 10 times 2 raised to the x. And we want to find it when we have week 9. So what we're going to do is we're going to plug in 10, we're going to plug in 9 in for that x. So 2 raised to the 9th power gives me what? So we have 10 times 2 raised to the 9th power. That gives us 5,120. Okay, so on the next one, what I want you to do is I want you to write the explicit formula, and then I want you to plug in 5. So remember the explicit formula is going to look like this. It's going to have a sub n equals a sub 1 times r minus n minus 1. So all you are going to do is you're going to plug in the initial value and the rate and leave everything else alone. Take a second, try that one. Okay, so this is going to give me a sub n equals, what's my initial value? 40. What's our r? 1.5. And then if we're plugging in for our 5th term, we're going to plug 5 in for n. So we're going to say a sub 5 equals 40 times 1.5 raised to the 5 minus 1. Okay, so if we take that and we plug it into our calculator, then I'm going to get 202.5. Okay, so on this first one, it says, how are geometric sequences related to exponential function? How are those related? Yes, Sean.
Both of them are not going or going down or up by consistent rate.
Okay, so both have a ratio.
Yeah, you got it.
Okay, both have a ratio that they're going up by or being multiplied by. And that is so blurry. Okay. That's not. No, it's definitely the board. Okay. Okay, so both have a ratio that they're being multiplied by each time. Okay, so how are geometric sequences similar to arithmetic sequences, and then how are they different? Go ahead. Hey, if you're not shying, you should be talking. Shh. Go.
Are different from arithmetic sequences because arithmetic sequences is linear and then like geometric sequences is exponential.
Okay. All right, how are they similar? Both have a number, what? they have an initial value, okay, and they're going at a continuous rate, either adding or multiplying, right?
They both have the same end goal in number.
Okay. So both have patterns, okay, whether that be adding or multiplying. Okay. All right, on the next one, it says for a geometric sequence with a sub 1 equals 3, the R is 1.25. Jamie writes this equation. What mistake did Jamie make? What mistake did Jamie make? Yep. Okay, so these are swapped. So it should have been 3 times 1.25 raised to the n minus 1. Okay. What'd you spell? Okay, determine whether the sequence is arithmetic or geometric. If it's geometric, what's the common ratio? Okay, so are we consistently going? Yeah. Right over there. Okay. So are we consistently going down by something?
Yeah.
What are we going down by?
They're going down, dividing by 5.
We skipped number 4.
Dividing by 5 every time.
We're dividing by 5, so that ratio is going to be 1/5. Okay, because if we multiply by 1/5, then it would be dividing by 5. So this is geometric because we're multiplying by a common ratio.
No, we're dividing.
So we're multiplying by 1/5, which is the same thing as dividing by 5. Okay. All right, on the next one, are we multiplying by a common ratio? Okay, what is that common ratio? Okay, so our ratio is 4, and it's geometric. Okay, remember, with geometric, it has to work for all those numbers, right? So we have to be able to multiply by 4 each time. Okay, on number 7, okay. So on the next one, it's asking for us to write the recursive formula. Okay, so the way we do that is we say a sub n equals r times a sub n minus 1. So we're going to keep that a sub n. We're going to keep that a sub n minus 1. How do we find the rate?
You divide for it's like down, right?
Yeah.
So you divide 640 divided by 160, you get 4.
So we should divide the second one by the first one. And what are you going to get? 0.25. Okay. All right. Did you finish 8, 9, and 10? Okay. All right. Looking at number 8, we're going to write the recursive formula for this one. Again, here's our recursive formula. All we're going to do is fill in what r is. So we're going to keep the a sub n. We're going to keep that a sub n minus 1. For r, we're going to take the second and divide by the first. And so that's going to give us 2.5. Okay, and so we plug that in for our rates. Okay, on the next one, it gives us the explicit, but we want to write the recursive. So what is my rate on this one? 3. So we're going to plug that in. And we're going to keep the rest of it the same.
You add those apostrophes like between the word and 5, right?
Apostrophes between. Okay, a sequence has an initial value of 25 and a common ratio of 1.8. How can you write the sequence as a function? So if we're writing this as a function, okay, we're writing this as an explicit formula. So we've seen this the past couple of weeks. So our initial is 25. Our rate is 1.8, and we're raising it to the x. So there is a difference between writing it as a function and then writing it as the explicit formula. Questions over that?
No, ma'am.
We're good.
This is an easy assignment.
Good.
Some of the blanks will take time to the future. Oh, so wars.
Right.
Whenever you feel like I need to watch something, you're the opposite.
What you're gonna do is you're gonna grab one of these books. That belongs in my classroom. You take this book, then I'm going to. Don't take my book. Don't take my book. This has to go back to the ISP, which is our instructional support center. So we don't have this book. It stays in the classroom. The workbook you take with you. The textbook stays here. Okay, what? Yeah. Okay, you're gonna come get one of these books. You get a piece of paper. Okay, so go ahead and come grab one. You need a piece of paper. Go ahead and come grab one. You need a piece of paper.
Grab one, boy. Grab me one. Dad, if you have a grab one, can you grab one, please? Excuse me.
Hey, Daddy.
One for you, Dad.
Okay. You got it to me. Appreciate it.
No.
Give me my water back. No, you boy.
And this is gonna be part of your homework if you don't get it done. That's what please. Okay, so your return 251. Problem 17, 19, 21, 27, 29, 31, and 33. There's 8 problems. Your job is to write down the problem, write down what it's asking, and then solve the problem. If you don't get that done in the next 10 minutes, then you have homework. No, you cannot take my book home. So either A, you need to take a picture of it, or B, you need to write quickly. One of the two things. But these loud conversations are going to stop today before I start making phone calls home and writing you up. It stops today. Does everybody understand?
Yeah.
251. Write those problems down. So you should be on a clean sheet of paper. At the top of your paper, you write page 251. You write all those problem numbers down. Then on the side, you number them and write the problem.
Please.
Stop talking so loud. Down the question numbers up at the top of your paper.